Okay, let's keep an eye on this thermometer, turn on my vacuum chamber and see how it changes. So right now it's hanging out around 17 degrees Celsius. Okay, measuring the temperature of space. 3, 2, 1. Looks like the temperature's going down pretty quickly actually. So after this is done, I'm going to explain why it's acting like this. I'm going to explain why it's acting like this. I'm going to explain why it's acting like this. And is this really the temperature of space? So we started at 17 degrees, we're at 13 degrees now. I'm getting colder. 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 So it's starting to not drop as fast. Okay, we're at 11 degrees Celsius, 11.1 degrees. Not much happening now. Okay, we're at a pretty good vacuum at this point. It's climbing back up now. Okay, so what happened there? Why did that decrease as soon as I turned on the vacuum? So the reason it decreased right away is because it's filled with air initially, and then I turn on the vacuum and it sucks out the air, and the air expands. The air expands. The air expands. The air expands. But expanding a gas like that reduces the temperature. But expanding a gas like that reduces the temperature. But expanding a gas like that reduces the temperature. So the temperature of the air that was in there got colder. So the temperature of the air that was in there got colder. So the temperature of the air that was in there got colder. So the temperature of the air that was in there got colder. The thermometer picked that up and it showed it was getting colder. But after a while, it sucked out all of the air. The air wasn't expanding anymore. It was a really low vacuum in there. And eventually there was no more expanding gas, and it was a pretty good vacuum in there. And there's nothing to dissipate the heat from the thermometer. And so the residual heat that was in the head here and some of the bar there eventually made its way back down to the end of the thermometer, and that made the temperature go up until it reached an equilibrium temperature of around 14.9 degrees Celsius now, because it lost some heat as the gas expanded. Because it lost some heat as the gas expanded. Because it lost some heat as the gas expanded. But that's nowhere near the end of the story. If you were to go into space, you would for sure freeze if you had no heat generation. And that's because you have to remember that even though there's nothing to conduct heat away from you, you still lose heat. That's because you have to remember that every object is continually emitting radiation. That means it's emitting heat. But this is heat that's in radiation form, so it's photons leaving your body. And that's continually happening. But we don't really notice it here because you're continually emitting radiation and you're absorbing radiation. And so you kind of stay at this happy equilibrium. But in space, you emit radiation, but you never get any radiation absorbed back into you when there's nothing around you. And so you just emit radiation and you get colder and colder and colder and eventually freeze. Now, if you were closer to the sun, then it's going to be a different answer, because there you would absorb radiation from the sun. Okay, now I should film what happens when I put the air back in. Okay, letting air back in the vacuum. 3, 2, 1. So it got warmer than it was before. So just the same reason that the temperature went down when we turned on the vacuum, the temperature increases because we put in air, and so that what was inside of there got compressed, and that heated it up and made the temperature go up.